right, so you don't have to write this down. When we have problems with more than one vertical asymptote, we're going to find our vertical asymptotes by factoring that denominator out. Once we factor the denominator out, we'll be able to identify those excluded values. Those excluded values drive our vertical asymptotes. All right, so let's look at this first example. Now the denominator is already factored, so it's saving us a little bit of work. If you look at the denominator, can you identify the excluded values? What are my excluded values? -2 and +3. So those excluded values are going to be our vertical asymptotes. So x equals -2 and x equals +3. So I'm going to graph those two vertical asymptotes. So I've got one at -2 and I've got one at +3. Now, do you see anything added or subtracted from the fraction? No, so my horizontal asymptote is 0. We'll see some examples down below these three where you'll have something added or subtracted to the fraction. Those will be our horizontal asymptotes. So this one's just going to be y equals 0. Y equals 0. So at this point, I should have, I think of this as I have like 6 little panels. Do you guys see that? Okay. So I'm going to add a page just really quickly. And I want to reflect for just a minute when I had something like y equals maybe 5/x². All right, so I had a vertical asymptote at y equals 0, horizontal asymptote at y equals 0. And then as I approach this vertical asymptote, what happened to the y values? If you were going to graph this, what happened to the y values as I approach the vertical asymptote? They're increasing, right? So I had this curve like this. All right. Then if I had, maybe if I had y equals -4/x², this, I have the y values decreasing. Does this hopefully look familiar to you? Y equals decreasing. All right, so what we're going to do today, though, is we're going to take these same graphs and we're going to split them further apart and add a panel in between them. So what you're going to end up drawing for me today, here are my two choices. I'm going to have a couple vertical asymptotes. Maybe they're here, maybe they're here, maybe they're here, maybe they're here. If my A value is positive, my outside curves are going to look like this graph up here. So my outside curves. And then the inside is going to do the opposite. So if I split this graph apart, imagine pulling this apart, I'm going to have my outside curves going down, right, just the way that this went down, and then my inside panel is going to go the other direction. It's going to kind of make a U shape. No, it's just a graph that's approaching all those asymptotes. It's approaching the asymptote on the left, it's approaching the horizontal asymptote, and then it's approaching the asymptote on the right. So this is what all your graphs are going to look like mostly today, if it has two asymptotes. Okay? So I look at the outside curves and an inside curve. The inside curve is going to go opposite the outside curves. All right, so let's go back to our example here. So I have a positive A value. So if I think back to when I just had 4/x², those curves, as they were approaching the vertical asymptote, the y's were increasing. So my outside curves are going to look just like that. It's just now we're going to have a gap in between, right? If you didn't have this gap in between, would that look over like 4/x²? Now your inside curve is going to be in the panel in between, okay? And it's going to go the opposite direction. So you're just doing a sketch for me. Yes, ma'am. Sure. You can give me one exact point. and that's going to be down here on the bottom. So the exact point, and we're just going to use this to double check what we sketched. We're going to find our y-intercept. So our y-intercept is my value of y when x equals 0. So I'm going to go to my original equation here, and I'm going to put a 0 in place of both of those x's. So I have 4 over 2 times negative 3. 2 times negative 3. So 4 over negative 6. So that reduces to negative 2/3, right? So 0 comma negative 2/3. So I'm going to look at my graph and say, is it reasonable? Does my graph look like it's going through 0, negative 2/3? Well, maybe if I did a little bit of a better job right in here, right? There we go. So that helps me determine I'm in the right panels. All right. So the last thing we need to do is we need to write our domain and range. I've got 2 vertical asymptotes. That means I've got 2 breaks in my graph. That means I'm going to have 2 unions in my domain. So I'm starting at negative infinity, and I have a break at negative 2. And where I have that vertical asymptote, I'm going to have a union. Then I pick back up at negative 2, and I go to positive 3, and I have a union, and then I go from 3 to infinity. All right, so 2 vertical asymptotes, 2 breaks in my graph. How many horizontal asymptotes do I have? 1. So how many breaks am I going to have in my graph? 1. And I'm going from negative infinity to 0, and 0 to infinity. All right, so the only thing that you might see some examples tonight that are already factored for you, or you might see more like we have in letter B. So in letter B, I have standard form quadratic. So I need to find the excluded values. To find those, I have to factor the denominator. Remember I said we're going to get really good at factoring? Yes, we are. All right. So I'm going to factor the denominator here, and I'm going to get x minus 4 times x plus 1. So this is going to determine my excluded values. Milani, what are my 2 excluded values? Milani. X equals negative 1, and what else? Thank you, Milani. Not you. Jeez. So here are my vertical asymptotes. My excluded values are my vertical asymptotes. So now I can draw those. Negative 1 and positive 4. 1, 2, 3, 4. And again, I'm not adding or subtracting anything from the fraction. So I have a horizontal asymptote at y equals 0. So I'm going to add that. Y equals 0. All right. My a value is negative this time. So basically everything's going to be flipped of what we did in this first example. My a value is negative. So my outside curves, the y's will decrease as we approach those vertical asymptotes. And then my inner little panel here will go up. It's just part of the graph. If you were to pick a whole bunch of x values, if you were to pick an x value at 0 and 1 and 2 and 3 and 3.5, you're going to end up plotting points along the curve like that. Okay? Yes. Okay. So my domain. We'll fill in the domain here. So I'm going from negative infinity to negative 1. These order matters here, guys. From negative 1 to 4, we go from left to right, and 4 to infinity. Negative infinity to 0, and 0 to infinity. So this last little bit, you can do it first if you want. You don't have to wait to do it to the end. Sometimes if you plot that point, that'll help you know, hey, wait, which way am I supposed to graph my curves? So my y-intercept. Now, I think it's easier to use the original equation because I can put a 0 in place of x, a 0 in place of 3, and I end up with -1 over -4. That's my y-intercept because I put a 0 here and I put a 0 here. So my y-intercept is 0, 1/4. And I just want to kind of spot check my graph there. When x is 0, y is 1/4. I'm on the right side, right? It's right over there somewhere. So I should feel pretty good about which panels I chose to draw curves in. Let's jump down. I mean, do you think we need this next one? No. I mean, it's because it's going to look a whole lot like the first one. The only difference graphically is I'm going to have vertical asymptotes at -3 and +3 instead of what I had over here. So let's jump down to one of these. So pick one of these, any one of these that you want. You want to do H? Let's do H. Okay. Get that out of the way. All right. So the first thing I'd like to do is I'd like to factor my denominator. So if I factor my denominator, I have x plus 6 times the quantity x plus 2. Take a second to FOIL that out in your head. Done. FOIL that out in your head so you don't have signs that are flipped. So x squared, 6 plus 2 is 8. 6 times 2 is 12. So I'm in pretty good shape. So what are my two excluded values here? -6 and -2. So those are also going to be my vertical asymptotes. So -2 and 3, 4, 5, 6. Here we go. Now I do have something that I'm adding or subtracting from the fraction, and that's -2. So that will be my horizontal asymptote. My horizontal asymptote is y equals -2. Okay, this is going to be my k value, driving that horizontal asymptote. I still have the same 6 panels. Thank you. So since my a value is positive, I can draw my outside curves. All right. Then the inside curve is going to be on the other side of that horizontal asymptote. If I want to find my y-intercept, which I think I'm asked to do, so I'm going to put a 0 here and a 0 here. So I end up with 6 over 12, which is 1/2. Right? So what's 1/2 minus 2? -1.5. All right, so does it look like when x is 0, y is at -1.5? Yeah. So I should feel pretty good about my drawing. So 0, -1.5. And then we're going to notice a difference with our range than we've seen before. Instead of going from -infinity to 0, I'm going to go from -infinity to -2. And then from -2 to infinity. This still has 2 vertical asymptotes, so I'm going to have 2 breaks. -2. And these have to be in this order, from smallest to largest. How are you guys feeling okay with the graphing? Yeah. All right, then let's move on. Let's look over at the right side of your paper. So the other thing you're going to do is you're going to write equations given the graphs. All right? So just like we did yesterday, the first thing you're going to want to do is draw your asymptotes. So I have an asymptote here, I have an asymptote here, and I have a horizontal asymptote here. I have an asymptote here, I have an asymptote here. Now, we have to be really careful with this one. You want to line up with the outside curves because there's some stretching happening. So as long as you draw your horizontal asymptote close to the outside curves, you'll be in good shape. All right, so now we have to find the value of A, just like we've done all year long. We're going to plug in As much as we know, we're going to plug in and solve for A. We're going to plug in our point that's given up there, x and y, and solve for A. All right, but before we solve for A on number 1, what do you know about what should the A value be in terms of signs? It's going to be negative. Now, don't just make it negative. We're going to solve algebraically. If solving algebraically, you don't get a negative answer, that's your clue you did something wrong. All right, so let's start by filling in what we have. So I have an equation. I don't know what A is. I know when I'm done it's going to be negative, though. I've got a vertical asymptote at x equals -2. So when I write that in factored form, I have x plus 2. Right? Graph shifted 2 units to the left. If I shift a graph 3 units to the right, this will be x minus 3. And then I'm going to write plus 0 here, but you don't have to write it. I just wanted to point out if your y, you've got a horizontal asymptote, you make sure you include it in the equation. So we can pretty much ignore that plus 0. And you don't even have to write it. I just wanted to kind of show you the components. All right, so up here at the top of the page, I have an x value of 2 and a y value of 0.25. So I'm going to replace my y with 0.25. And everywhere I have an x, I'm going to replace it with a 2. I see a fraction, so I'm going to set a fraction equal to a fraction so I can cross multiply. So I have a equals 0.25 times 4 times -1. Well, 0.25 is a fourth, and a fourth of 4 is 1, and 1 times -1 is -1. But if you want to type that into your calculator, you can do that as well. So I did have a negative a value. So I'm going to rewrite my equation. I'm going to cheat and do it like this. Rewrite the equation with my -1. And then here's my final answer. All right, you don't have to put the 0 in there. So I found my a value. I plug it into the original equation. What can you tell me about the a value of this last one? We know it's going to be positive. All right, so I'm going to start with y equals a over x plus 5 times x plus 1. And I need to solve for a. I know a is going to be positive. And I'm given an ordered pair, an xy value here of -1.25 and -3. -1.25 and -3. So everywhere there's an x, I'm going to replace x with -3. I can set this over 1, and I see that a is going to be equal to -1.25 times 2 times -2. So let's see, I know this is -5 over 4, and this is -4. So this cancels this, and I get an a value of 5. But you can type that into your calculator if you'd like. I'm going to so a, oops, I'll do this one. A is equal to +5. So here's my final equation.